Now, this is one of the most misunderstood concepts, so please pay attention. CAP stands for consistency, availability, and partition tolerance. Let's try and understand each term one by one. Consistency means that all the database servers will return the same data at the same time, which means that the data is consistent across the servers. And to achieve this, whenever data is returned to one database server, it must be instantly forwarded or replicated to all the other servers in the system before the write operation is considered successful. Okay? Next is availability. Availability means that any client making a request will get a non-error response even if one or more servers in the system are down. Mind you, this doesn't guarantee consistent data. It just guarantees that you will get some version of data. It can be a recent data or an old version of data. Okay? Next is partition tolerance. First of all, what is a partition? Within distributed systems, the servers constantly communicate over the network to achieve consistency. Now, this network may delay or drop the messages sometimes. And this is what we call a network partition. And because of network partitions, servers might not be able to communicate properly. So partition tolerance means that your distributed system is tolerant to partitions, which means that your distributed system will continue to function as a whole even if some servers are not able to communicate. Actually, you don't have any choice here. In a network, partitions are bound to happen. So you don't have any choice but to tolerate these partitions, which means that there will be times when the servers in your distributed system won't be able to communicate with each other. You cannot escape that. Okay? So every distributed system is by default partition tolerant. If it is not, you don't have a distributed system. Okay? So now that you know the meaning of the individual terms, let's understand what is CAP theorem. So CAP theorem states that in case of network partition, you can either make your system consistent or available, but not both. Let's understand this using an example. Suppose there is a banking system which has a database containing users' balance information. And whenever users deposit or withdraw money from the bank, the same gets updated into this database. Now suppose over a period of time, the number of clients increased, and now a single database server is getting overloaded. So obviously the bank will add more database servers to handle the load. Now suppose a user account has a balance of rupees 1000 and the user wants to withdraw rupees 500. So he will send a request to the system for the same. And suppose the request went to server A. And so the balance will be updated on server A. And then server A will communicate the same to server B. And then server B will update the balance as well. Once this process is completed, the system will dispense the money. This is consistency because both the servers have the same data. Perfectly fine, all good. Now suppose there is some network issue in the system because of which server A is not able to communicate with server B and vice versa. And now let's say the same user wants to withdraw rupees 250 from his account. Again, he will send the request to the system, and suppose the request went to server A, the balance was updated on server A, but now server A won't be able to communicate with server B. Now let's recollect the CAP theorem. It says that in case of network partition, which is happening in our case, you can either make your system consistent or available, but not both. Now in our example, If the system dispenses the money, it will be called an available and an inconsistent system because it gave a non-error response to the client, but the data in the servers is now inconsistent. On the other hand, if the system rejected the request by sending a message like, "Sorry, we can't dispense the money because of some issue," and rolls back the update on server A to the previous value, which was 500, our system will be called consistent but unavailable because the data will now be consistent, but the system didn't dispense the money and sent an error response. Okay? So you need to choose between the two because in a distributed system, network partitions are bound to happen. You can't avoid them. You can spend some money to make network partitions less frequent in your system, but in the real world, no distributed system is completely immune to network partitions. Okay? So now the question arises when to choose consistency and when to choose availability. Well, for a system like, let's say, a banking system, because money is involved, you must choose consistency over availability. But for something like, let's say, comments on a social media platform, you can choose availability over consistency because in case network partition happens, the other servers will be updated once the issue is resolved, which means that some people will be able to view the comments with some delay, and that's okay. So in system design interviews and in real world projects as well, you need to choose between the two. Okay? So I hope you understood what a cap theorem is. If not, I will highly suggest you to watch this lecture once again. Okay?